There we go. Now, with example 8, one of the things that you guys will notice, yesterday we talked about equations that had radicals in them, right? We had a 4-step process, didn't we? First step was isolate the radicals. Second step, raise both sides to that power. Third step, solve the resulting equation. And what was that fourth step that we said was oh so important? Luke? Plug it back in, check, make sure it's not an extraneous solution, okay? Then now you look at an equation like this and you might think, well, crap, that goes right out the door because this ain't even what he's talking about. This ain't even a radical equation. And yet, if we remember, as I say here in the note, the phrase that pays is power over root. Anytime you have a rational exponent. What is rational exponent, Paul, as you cover your mouth? What does rational exponent mean? The word rational. All right, so 0.5 is an example of a decimal that is rational. James, what do you think when we say rational? Like, what's a rational number? What does that mean? And I'll give you a clue. It's the base of the word rational. Yeah, it's a, ooh, that's hot. It's a number that can be expressed as a ratio of integers. So when I say, hey, we've got a rational exponent, all that means is a fraction. Your exponent being a fraction. I want you to write down that when I see a fraction as my exponent, that's the same thing as a radical. And the key to that is the phrase that pays, power over root, okay? And so when we look at, there's going to be two ways that we can work an example like example 8. I'll do one of them in blue and one of them in red. When we look at a problem like that, the first thing we could do is we could go ahead and express it as a radical. So 3x minus 2 is raised to the first power, and it's under the fourth root. That's power over root. Notice I didn't go to the trouble of writing it to the first power, though, right? It's very atypical. Would you see somebody say this expression raised to the first power? But that's precisely what we're talking about. Power over root. Okay? So that rational exponent, we could express that as a radical. Okay? I'm actually going to go ahead and get that 1 out of the way there. And now, let's see if we can work this one out following our 4 steps from yesterday, right? The first thing, Drew Benton, I want to do is what? Nice, easy first step. Speak up. How so? Very good. We're going to subtract 3 from both sides. 2. All right, Jack McBee, what is my next step?
Raise everything to the fourth power.
Correctamundo. We're going to raise everything to the fourth power. Now, Tiago, do you remember what 2 to the fourth is? Good. So we got 3x minus 2 equals 16. All right. Mossy, what kind of equation is that? Is that a quadratic equation that's going to have 2 solutions? It's a what kind of equation? Very good. And it's going to therefore have 1 solution. All right, so we'll add 2 and we'll divide by 3. So we get x equals 6. Okay, you guys should be able to do that in your head at this point. X equals 6. Now, I can't run with that and say, that's my answer. Instead, I should do what? Plug it in, plug it in. Old Glade commercial, right? Plug in 6. Now, 6 times 3 is 18 minus 2 is 16. The fourth root of which is 2. 2 plus 3 equals 5. So that does check out as a true statement. Okay? And as I mentioned a moment ago, this is one way of working it. Another way of working it is just to leave it in exponential form. Don't bother with translating it into a radical. Did you know that you could do the exact same? You could follow the same process, right? With rational exponents. Check this out. 3x minus 2 to the 1/4 power plus 3 equals 5. Okay? And if I just subtract 3, and then I ask the question, okay, what could I raise both sides to in order to cancel that 1/4 out? What could I raise both sides to the power of? Paul, cover your mouth up. It was already 1 over 4. So if I did 1 over 4 again, that would be 1 over 16, because with power of a power exponent rule, we multiply. So you would say what? Yeah, we would raise both sides to the 4th power. Whatever I do on the left, I got to do on the right. And then those cancel out, right? So what this does is this opens the door for a shortcut later on. Okay, and then, you know, dot, dot, dot. We got the same thing. 3x minus 2 equals 16. X equals 6. Wham, bam, thank you, ma'am. All right. But what this is going to allow us to do is it's going to allow us to work problems of similar structure that might take a little bit longer going the blue route. We can work them a little bit quicker going the red route. Okay? Here, let me get you guys one to practice. 4x minus 8 plus, that's the 1/4 plus 5 equals 7. This car horn is reminding me of a fabulous story. Remind me to tell you about an attempted car theft. After this example, don't let me forget. Attempted car theft. Drug at x equals 6. All right, good, good, good. We subtract 5, we get 2. 2 to the 4th again is 16. Add 8 this time, we'll get 24 divided by 4 is 6. And when we plug it in, we get a true statement. Very similar example. Car theft. Friday, you know, we had a half day, right? Did you guys know that? Christian Brothers had a half day Friday for the purpose of teachers going across the street to Baptist and getting vaccinated. Okay. And so a lot of teachers went over there and parked the car. You had to get out, go inside the building, blah, blah, blah. Did your mama do it? Or she already have hers? Gotcha. Yeah, I already had been vaccinated, so I just took the half day and went and played with my kids. But a lot of our teachers went over there, okay? And 2 of them left their cars unlocked. They just, you know, parked, got out, went in, left their cars unlocked. And apparently there was a naughty person in the parking lot, a ne'er-do-well, one might say, that was walking around checking handles of cars. And if the handle opened the door, he thought, "Ooh, free goodies," and he would go in the car and ransack it and take whatever he wanted. And so this happened to one of our coach's cars, and then the fellow moved from that car to the next car over. It's another coach that parked next to him. His car was unlocked, so the bad guy opened the car up, and as he was going through it, what do you think happened? The coach came out. Now, this was a wrestling coach. This was our head wrestling coach, okay? Now, if you wanted to pick a fight with somebody in a parking lot, it might not be somebody who knows or who is like they're a professional fighter, okay? Which is pretty much what a wrestling coach is, right? So anywho, this dude tries to run and Coach Harrison just tracks him down, takes him down, and then like I don't know what kind of hold he put him in, but like put him in some kind of like you're not going anywhere, boss, and held him there, and then just called the police, and the police came, and the dude tried to escape, and it took him like 20 minutes to get there, and Coach was just like, "Nope, you're not going anywhere. Just quit fighting." And the poor sap, got arrested, and he had pockets full of goodies that he had been stealing from cars. But isn't that hilariously bad luck on that thief's part? To have picked the car of the wrestling coach at the moment that the wrestling coach came out, and then to get owned like that, just got to be embarrassing for sure. All right, now let's talk adjustments here. Now that we've gotten a few examples, under our belts, let's talk adjustments. Yesterday, sort of the curveball that we looked at, right, was we said, okay, well the 4 steps work nice and easy when there's one and only one radical. What do you do if there's 2 radicals? Okay. So in this case, what we're going to do is we're going to follow our same 4 steps. We're going to isolate a radical, raise both sides of that power, and then repeat the process as needed. But let me give you a little additional piece of information here. Okay, with step one, I like to pick or pick the radical with the more complicated radicand. All right, so I like to isolate the radical that has the more complicated radicand first. That makes life just a wee bit little bit easier. Okay. So in that case, actually that's already done for us, right? Between q minus 2 and 4q plus 1, 4q plus 1 is just a little bit more complicated, so it would be a good convention to just isolate that one. And it's already isolated, and so that's kind of nice. They've done the work for us. Okay. And could you solve this by isolating the first radical? Of course, just subtract 3 from both sides and then work the problem. It makes it a little bit nicer if you, especially if there's going to be a coefficient in front of the variable in one of them. That's usually a good one to isolate. So in this example 10 right here, we've got that radical already isolated. So what are we going to do to both sides now? We're going to square both sides because they are square roots. If they were cube roots, we'd cube both sides. If they were fourth roots, we would raise both sides to the fourth power. All right, but in this case, what we're going to do is we're going to square both sides. Y'all do that with me here. And I'm going to caution you, yesterday in our warm-up questions, you might remember there was an opportunity to get a swift kick to the gonads, right? Because when we square a binomial, it does not, by any means, mean that you square the first term, square the last term, and you're done. Okay, so again, I will caution you. A plus B quantity squared does not equal A squared plus B squared. Okay, instead it is a FOIL problem. You couldn't see I was making the F sound because I had my mask on. It's a FOIL problem. Now, what do I mean by FOIL problem? It's a binomial times a binomial. It's 2 terms times 2 terms. And you might say to yourself, well, wait a minute, what the heck are you talking about 2 terms? Look, A plus B right there. A plus B quantity squared. That's what it is. Now, you certainly don't need to write it like that, but just work it like that, okay? So Q minus 2 plus 3. Q minus 2, there we go, plus 3. And I'm taking my time. You by no means do you have to do this every time, right? But when we're working out a FOIL problem, sometimes it's helpful to show all 4 of the multiplications, because that's what it is. It's just distribution of a binomial times a binomial. 2 terms times 2 terms equals 4 terms before simplifying. All right, so when I multiply the first times the first, I'm just going to get q minus 2. Isn't that right? Square root times itself. In other words, squaring a square root is going to cancel it out. So we just get q minus 2. Okay. When I do the outer, Charlie, what do I get? When I multiply the outer 2 terms. Three times the radical. And then when I do the inner, I'm going to get the same thing, right? 3 times the radical, q minus 2. And then last times last. Oh, that's so easy. I love it. Last times last. It's just 3 times 3, that's 9. And I'll put that over here. Did you notice how I kind of lined them up based on like terms? Okay. So we got q minus 2 plus 9. So what is that? Q plus 7. And then 3. No. What? What did I do wrong there? Brain fart. What should it be? 6. 6 quantity, or radical q minus 2. All right. So that's what my left side is going to actually boil down to. So I can come back kind of over here. I was doing some marginal work there. I come back over here. I can say, all right, q plus 7 plus 6 times the radical. And then what is that right-hand side going to equal there, Joe? We did the left-hand side. We FOILed the left-hand side. The right-hand side's a lot simpler. What is it just going to simplify down to? Right up here. We squared a square root. So did you see how I scratched them both out? What are we left with? Yeah, 4q. Oops. plus 1. Okay, so in other words, what we started with was an equation that had two radicals. We isolated one of them. We squared both sides in this case, and we got rid of one radical. So now we're down to an equation here in green that has how many radicals left? 1. So if you look back at your step-by-step process, look at what they say here. I'll highlight it. It says if you have another radical, just go back and rinse and repeat. Okay, go back to the top, do it again. So now I want to isolate the radical. Okay, so why don't we subtract q from both sides? Subtract 7 from both sides, right? 6 times the square root, 3q minus 6, okay? At this point, sometimes students go ahead and divide both sides by 6. I would not in this case because both of those terms on the right-hand side are not fully divisible by 6. Like if I divided this by 6, this by 6, this by 6, true, it would make the left-hand side just the radical, but I'd still have a fraction over here. And sometimes people make mistakes with fractions when they're foiling, because we're going to have to foil again, aren't we? You see the writing on the wall. We're going to square both sides again, repeating the first two steps, right? And so if I square this, sometimes students just mess up a FOIL problem if there's fractions in it. So that's why at this point I'd say, let's not divide by 6. You can if you want to, but I don't recommend it here because both those terms on the right-hand side they aren't fully divisible by 6. So instead, let's go ahead and square both sides. Let's do this. Square the left, square the right. Now you got to take your time. Well, I'm tired of telling you, son. Keep it up. You got to take your time when you're squaring out this left-hand side, because you must also not just square the radical, you must also square the C word, coefficient. Good job, Charlie. We got to square the 6 to get 36, and then we square the radical to make it go away. So we got 36, and then we got q minus 2. Okay. How about on the right side? Are y'all good enough to FOIL in your heads just yet? 3q times 3q is 9q squared. And then 3 times 6 is 18. Double that, you're going to get 36. And then negative 6 times negative 6 is 36. Okay. I suppose I could go ahead and distribute my 36 on the left. And then we can combine like terms. Now, I asked Mossy this question a minute ago. Ben, I'll ask you this time. What kind of equation is this? Good. It's going to have, therefore, two solutions. Now, I might be moving just a wee bit quickly, so I'll slow down just a sec, let you guys catch up. But look at what we did. From green to blue, we squared both sides. The left side was a couple of factors. It was a coefficient and a radical. So we had to square the coefficient and square the radical. The right-hand side wasn't a couple of factors. It was a couple of terms, so we had to FOIL it, right? I'm hammering you guys on the fact that when you've got a binomial and you are squaring it, don't just square the first term, square the last term. It is a FOIL problem, right? So you should be able to FOIL it in your head comfortably. If you are curious as to how we got this highlighted part down here to equal this highlighted part down there, just take a side margin and work out the FOIL real quick, right? 3q times 3q, 3q times negative 6, negative 6 times 3q, and negative 6 times negative 6. FOIL, combine like terms, and you get that trinomial right there, okay? And then we want to combine some like terms. I need a little more room. Hold on. Question, go for it, Paul. Who? Jake, sorry, go ahead. Yes, absolutely. To make the numbers nicer, you could divide by, I'm probably going to do that in just a second once I combine like terms. Subtract 36q, so subtract 36q, and add 72, Add 72. Oops. And so we've got 0 equals 9q squared minus 72q plus 108. Right? And then as Jake just mentioned, we can divide everything by 9. I'll be honest with you, back here at the very, not at the very beginning, but back here where before we squared both sides, right? We could have divided everything by 3. In retrospect, that would make our numbers a little bit nicer. You know what I'm saying? Instead of dividing both sides by 6, we could have divided everything by 3. So in retrospect, that would have made the numbers a little bit nicer, but they're not too bad. They're multiples of 9, and we can deal with multiples of 9. So dividing everything by 9 down here in blue, we get q squared minus 8q plus 12. And that's a quadratic equation. What did we say yesterday is the only method that you guys know for solving quadratics at this point? Luke? Yeah, factor that bad boy out and use the ZPP. Now, you probably already recognize -6, -2 as being the two factors. So q minus 6 and q minus 2. Therefore, q equals 6 or q equals 2. And then what do we want to do? We want to go back to the very beginning of the problem. And you might be thinking, gosh, dog, coach, this is a long problem. And you're right. So what do we do with 6 and what do we do with 2? Plug them in individually and double check, verify, in other words, to see if they are, in fact, legit answers. Let me erase all of this jibber jabber and we'll plug them in. Let's see here. All right, y'all help me out. We can do this in our heads. 6 minus 2 is 4. Square root of 4 is 2 plus 3 is 5 on the left. 6 times 4 is 24 plus 1 is 25. Square root of 25 is 5 on the right. Ding, 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 ding. 6 looks like a good number. Let's see if 2 does the same thing. 2 minus 2 is 0, square root of which is 0. 0 plus 3 is 3, so we got 3 on the left. 2 times 4 is 8 plus 1 is 9, square root of which is 3 on the right. Man, I really hope that does not be that horn is not going off all day long. I'm going to be going batty by the time that 8th period rolls around this afternoon, if that's the case. All right, so both of these solutions worked out, and that's an equation, therefore, that has 2 solutions, okay? Now, you guys, here's your last example. Y'all are going to try one, and this takes a little bit of time. So I'm going to give you about 4 or 5 minutes to chew on this one. Work on this one quietly. Think about your 4 steps. I've already got the more complicated radicand isolated, so you can go ahead and square both sides to begin with. Don't forget your FOIL process. As you continue working, I'm going to quietly and slowly start working this out so you can kind of spot check if you're stuck, double check to make sure you didn't make any mistakes. You may have worked it out just a wee bit differently. But as we walk through this process, first step is square both sides. The left side needs to be a FOIL. Okay. And you need to get to the point at which you can FOIL a binomial in your head. You can square a binomial in your head. That needs to be SOP, standard operating procedure for you guys at this point, right? It will pay off in the long run. And if you're not there just yet, trust me, I was not there until probably after college, okay? I was just, I don't know if it was OCD or just worried about it or what. I would always write my FOIL problems out. Finally, I just broke down. I was like, screw it. I'm going to learn how to do it in my head, and I'm going to get good at it. And you just rep it out. You practice a bunch, okay? So you guys, when we FOIL something like this, square that left-hand side, square the first term, square the last term, double the product. That's our shortcut, okay? And then isolate the new radical. So I subtract x, subtract 4. And at this point, you say, well, wait a minute. You're going backwards to what you said a moment ago. Earlier, you didn't divide by 4 because you didn't want to make a fraction. Yeah, that's true. But earlier, that right-hand side was also two different terms, and there was going to be another FOIL involved, right? So I'm not scared of a fraction if there's just one term. I can just square one term, right? I can square a half, square an x. That's easy. Because this wasn't a binomial, there wasn't this 4 canceled out. There was no FOIL to be done, so I was cool with just dividing everything by 4 to begin with. Okay. And so you isolate that second radical. You square both sides. Okay, so you get x. Here you get 1/4 x squared because you got to square the coefficient and square the x. And then what did I do from here to here? I did something interesting. What did I do from here to here? Drew? Why did I do that? Why did I multiply by 4? Yeah, to get rid of the fraction. So earlier I divided by 4, creating the fraction, just to get the radical by itself. And then I multiplied by 4. So if you wanted to be a little bit more efficient than I was, what you could have done is you could have just left it as 4 square root of x equals 2x, squared both sides, got 16x equals 4x squared, right? And then subtracted 16x from both sides and gotten 0 equals 4x squared minus 16x. That same quadratic, you would then divide both sides by 4, and you get 0 equals x squared minus 4x, which should be obviously the same thing that we got over there. So it's just a different way. One of the ways in blue was dealing with fractions. Don't be scared. And over here in red, we dealt with the numbers a little bit bigger and avoided the fractions. So again, just different strokes for different folks, okay? Point being, once you guys get down to this level, it's quadratic, and you ought to be able to solve quadratic, as Luke said a minute ago, using factoring in the ZPP in your dadgum sleep. Okay, we've done enough of those to where we should be real comfortable saying, oh, I'll factor out a GCF of x, and oh, I'll set the ZPP up and roll. Did you check both your answers? And they both worked out, didn't they? Okay, good, good, good. Now, let's talk homework. I put up last night, or rather yesterday morning, some Delta Math assignments, okay? And we're going to take a little quiz this week, probably Friday of this week. I don't usually give you guys quizzes and tests and whatnot, but I want to this week because we've been doing a lot of work with radicals, and I want to kind of check to see how you guys are getting along. So doing a little progress check. It'll be Friday, okay? Now, that being said, you got homework to do on Delta Math. Knock it out. Practice, 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 and then tomorrow we will we'll pick up. Excuse me, not tomorrow. Tomorrow's Wednesday. Thursday we will pick up with more stuff. Again, remember Thursday. I'm done with senior retreats on Thursdays now, so we'll be back in action on Thursday. I'll see you guys then. You guys online, y'all keep on keeping on and live Jesus in our hearts. Okay, thanks everybody. Y'all have a wonderful day. Be safe out there. It's supposed to get rainy this afternoon.